The joint hearing will come to order. Without objection, the chair is authorized to declare recess of the subcommittees at any time. Welcome to today's hearing titled Navigating the Blue Frontier, Evaluating the Potential of Marine Carbon Dioxide Removal Approaches. I recognize myself for 5 minutes for an opening statement. Good morning, and thank you to our witnesses for being with us here today. Today's hearing is on a topic that stands to increase in relevance as technology develops. Marine carbon dioxide removal, otherwise known as MCDR. It is also a special hearing because I am co-chairing it with my friend, Mr. Williams, the chair of the Energy Subcommittee, as we are conducting this as a joint Environment and Energy Subcommittee hearing. The field of MCDR presents a unique opportunity not only because of its immense potential benefits, but also because it builds off existing knowledge and research for land-based carbon removal that is already delivering results. Yet, at this very early stage of research, it is important to encourage involvement from a blend of federal agencies, private sector companies, and academia. In order for the field to grow, we must ensure that public-private partnerships work together to prevent duplicative efforts. In a step towards that, the Department of Energy and NOAA signed a memorandum of agreement that will establish a joint effort to enhance coordination, research, and technology development to advance the state of MCDR science. This is crucial to combating wasteful government spending. Combining NOAA's ocean science expertise with DOE's research and infrastructure will allow the federal government to operate efficiently and have the greatest possible impact. We cannot rely solely on federal agencies. However, as a robust private sector exploring all different types of removal techniques, it is critical to practical advancements. One of our witnesses today is representing Ebb Carbon, a private company that is pioneering one of the largest scale and lowest cost approaches to carbon removal by accelerating the ocean's natural ability to capture and store carbon. As a native Ohioan representing the 7th District of the Buckeye State, I recognize the potential of MCDR holds to the state's economy. The Great Lakes are the largest freshwater system on Earth, holding 95% of the United States' fresh water supply. They are some of the largest carbon sinks in the world, second only to the oceans. NOAA has established a constant presence in the Great Lakes with their acidification research and the Great Lakes Restoration Initiative. This work has been crucial to ensuring a successful future for significant fisheries and recreational tourism that create income and jobs for the region. It is my belief that studying how to remove and sequester that carbon will also prove critical to the long-term viability of the Great Lakes region. As we continue to innovate, it is important that the investments that we are making have the best path to commercialization. By having the federal and commercial sector utilize the research academia is producing, we will lay the groundwork for successful implementation of it. Through conversations like today, as we're talking about conservation, we can ensure that everyone is moving in the right direction together. I look forward to working with Chairman Williams and members of the committee to establish a common sense legislation that will create a well-rounded approach into this underutilized market. I want to thank all of our witnesses for being here today, and I look forward to each of your testimonies. I ask for unanimous consent to enter into the record a letter from the MCDR community in support of this hearing and future legislation, as well as a letter with additional background material from Dr. Julie Pullen of the Carbon to Sea Initiative. Without objection, so ordered. I now recognize the ranking member, the gentlewoman from North Carolina, for an opening statement.
Thank you, Chairman Miller and Chairman Williams, when he joins us, for holding this important hearing on an emerging field of science that could help mitigate the ongoing climate crisis. And thank you to our expert witnesses, some of whom I've met, for sharing your testimony and insights on this topic. The global climate is changing at an alarming and unprecedented rate due to ever-increasing atmospheric concentrations of greenhouse gases. This year alone, the U.S. has experienced the earliest Category 5 Atlantic hurricane on record. Massive tornado outbreaks, torrential floods, some of which we saw in my home state of North Carolina just this week, widespread wildfires, severe heat waves, and more. Around the world, extreme weather has become more frequent and more dangerous, and it's only expected to worsen. The longer we wait to aggressively combat climate change, the more we can expect devastating impacts to humans and the environment. The ocean is a natural sink of atmospheric carbon. In fact, in the more than 200 years since the Industrial Revolution, scientists estimate that the ocean has taken up 1/4 of the carbon dioxide that humans have emitted into the atmosphere. Marine carbon dioxide, or MCDR, aims to enhance the ocean's natural ability to absorb carbon from the atmosphere. This developing field holds great promise as a strategy to reverse some of the harm caused by a century of greenhouse gas emissions. However, there are still many uncertainties surrounding MCDR, including its effectiveness and some of its environmental impacts. By design, MCDR has the potential to significantly alter the marine environment. While we hope to use this to our advantage and sequester carbon dioxide, we must ensure that MCDR does not create yet another stressor for marine ecosystems and the human communities that are reliant on them, including along the coast of my home state of North Carolina. Dedicated and responsible research is necessary to grapple with these uncertainties and ensure that the field develops ethically and effectively. This research must be carried out in collaboration with communities that may be impacted, while leveraging partnerships across levels of government and with the academic and private sectors. In North Carolina, a form of MCDR using coastal olivine weathering is being explored by the company Vesta, and I look forward to seeing how the results of that work can inform the path forward. The potential for meaningful climate change mitigation through MCDR is exciting. But we must recognize the value of the ocean as a cultural and economic resource and do our best to ensure that MCDR approaches do not jeopardize our treasured coastline and marine environments. In today's hearing, we will explore the state of the science and discuss a responsible path forward. While MCDR and other emerging climate solutions may be critical to our endeavor to mitigate climate change, we must remember that the most straightforward path to keeping carbon dioxide out of the atmosphere is to reduce emissions. Carbon dioxide removal can be viewed just as one tool in our toolbox to combat climate change, but should not be relied upon as an excuse to avoid acting right now. We can and should act to decarbonize our economy today and as quickly as we can, and look to novel and innovative climate solutions, including MCDR, to help us remove legacy carbon emissions in the future. I look forward to hearing from our expert witnesses about the status of MCDR science and what Congress can do to support its responsible advancement. Thank you, Mr. Chairman, and I yield back.
Thank you, Ms. Ross. I now recognize the chairman of the Energy Subcommittee, the gentleman from New York, for an opening statement.
Thank you, Mr. Chairman, and thank you to our witnesses for being here. There's an extraordinary amount of innovation happening, and at the same time, an extraordinary amount of research happening to discover and measure the effect of the oceans on our climate, and particularly around carbon dioxide and carbon storage. And so that's what the focus of today is. You know, marine, as has been said, these MCDR is an up-and-coming solution, and we're here to talk about it today. We've seen development and progress in direct air capture technologies, certainly around the oil and gas industry have embraced these. People might overlook the fact that the ocean has the potential to hold up as much as 50 times more carbon dioxide than the atmosphere. And this potential could provide another avenue to regain United States energy independence while also being conscious stewards of the environment. Like most early-stage science topics, the federal research ecosystem is critically important and has started to build an understanding of the nuances associated with MCDR. Last year, the Department of Energy Advanced Research Project Agency, or ARPA, funded 11 high-risk, high-reward projects to support novel efforts to measure, report, and validate MCDR and identify cost-effective and energy-effective carbon removal solutions. This is the excellent work that the DOE ARPA program does. And in June of this year, NOAA announced a memorandum of agreement with the Department of Energy to ensure that ocean science expertise is combined with and utilized by Department of Energy research efforts. Separate from these public sector efforts, the private industry has been and will continue to be a crucial partner in facilitating the commercialization of these approaches and creating valuable byproducts that can thrive in the free market. Academia has also conducted crucial research that provides the foundation for advancement in the public and private sectors. In order for MCDR technologies to complete the path to commercialization, public-private partnerships synchronizing all of these efforts will be paramount. So thank you to our witnesses today. They are well-suited to discuss this and to bring this not only to the attention of Congress, but also to the attention of the public. We're going to cover such exciting topics as nutrient fertilization, ocean alkalinity enhancement, and direct ocean capture. I feel like I'm back in nuclear power school. All right, the approaches vary in the amount of carbon dioxide they can sequester as well as the duration of storage. Different approaches are at different readiness levels in terms of their technology and different stages of commercialization. All of these are fraught with risk, and I'm very happy that the Department of Energy is de-risking some of these strategies so that we can move on. Therefore, I hope today's hearing is a chance for us to learn how we in Congress can enable and accelerate the most promising innovations associated with MCDR. And as the chairman of the Energy Subcommittee, I want to ensure that the Department of Energy's world-leading resources serve as productive counterparts to NOAA's expertise in ocean science. And that is what government can do best, is to use our incredible investments in science and partner across agencies to keep the United States as a leader in these important endeavors. So thank you. I look forward to our conversation. And, Mr. Chairman, I yield back.
Thank you, Mr. Williams. I now recognize the ranking member of the Energy Subcommittee, the gentleman from New York, for an opening statement.
Good morning, and thank you, Chairman Williams and Chairman Miller, for convening this hearing today. And thank you to our panel of witnesses for appearing before the committee to discuss the importance of conducting well-coordinated research into marine carbon dioxide removal. My name is Congressman Jamal Bowman, by the way. The chairman didn't mention that, so I want to mention it. This research is critical not only to advancing technologies and methods that may significantly reduce greenhouse gases in our atmosphere, but also to informing us of any risk and potential unintended impacts of these approaches early on so that we can ensure that they have proper guardrails, and to better determine if any of these methods should ever be deployed at all. First, let's talk about why this is important. If we look back to DOE's 2023 Carbon Management Liftoff Report, DOE's modeling study suggests that reaching our energy transition goals could require capturing and permanently storing 400 to 1,800 million tons of carbon dioxide annually by 2050. Marine carbon dioxide removal seeks to enhance the already large role that the ocean plays as a naturally large carbon sink, and several of these approaches have a substantial potential to help our planet meet these targets. However, many of these emerging technologies and methods are far from ready to be deployed, and some may pose risks that are greater than we should be willing to accept. These technologies continue to require extensive research to understand their efficacy in storing carbon and any ecological impacts they may have. We all understand the vast importance of the ocean to our ecosystem and communities. So we want to make sure that Congress and the federal government have all the data they need to make informed decisions on these technologies before they are used on a widespread basis. That is why this committee is developing legislation to better coordinate our research and develop efforts between the Department of Energy and the National Oceanic and Atmospheric Administration. Coupling DOE's incredible network of national labs and research infrastructure with NOAA's world-class expertise in ocean science will ensure that our academic institutions, local communities, industry, and ultimately U.S. policymakers have all the tools needed to fully understand the benefits and risks associated with this carbon removal pathway. With that, I want to thank our excellent panel of witnesses for being here today, and I look forward to hearing your testimony. I yield back.
Thank you, Mr. Bowman. Let me now introduce our witnesses. Our first witness today is Mr. Noah, I'm going to struggle, Deitch. Is that correct? All right. Thank you, both. Noah Deitch, Senior Advisor at the Office of Fossil Energy and Carbon Management of the United States Department of Energy. Our next witness is Dr. Sarah Kapnick, Chief Scientist of the National Oceanic and Atmospheric Administration. Next, we have Mr. Ben Tarbell, CEO and co-founder of Ebb Carbon. Finally, we have Mr. Scott Dawney, the Joe D. and Helen J. Kington Professor in Environmental Change at the University of Virginia. With that, I now recognize Mr. Noah Deitch for 5 minutes to present his testimony. Deitch, my apologies again.
No, thank you, Chairman Williams and Miller, for welcoming me here. Thank you, Ranking Member Bowman and Ross, and all the members of the subcommittee. I'm very grateful to be able to testify here today and to speak about the Department of Energy's work on marine carbon removal. I also want to acknowledge the committee's longstanding work on carbon removal overall. Some of the hearings over a decade in this committee helped inform me about the potential and the need for carbon removal. And I co-founded a nonprofit dedicated to carbon removal back in 2015. Most of the time when I talked about CDR, nobody had any clue what those three letters stood for back then, but this committee and the staff were always incredibly knowledgeable and leaders on this topic, and I'm very grateful for the continued support. We've also seen the carbon removal conversation mature massively in the past decade, and marine CDR, I think, is one of the maybe late starters, but very important pieces of that equation. Academic studies and independent engineering assessments have shown just immense potential for this suite of solutions, not just to tackle the climate crisis, but to create jobs for coastal communities and to protect our vital marine resources. Yet many challenges remain, as have been noted already. From understanding how ocean biogeochemistry responds to various marine CDR interventions, to developing the nascent policies and markets needed to bring solutions to scale in a responsible manner. That's why I'm really proud to work on the Department of Energy's Carbon Negative Shot initiative. This is one of the department's many innovation moonshots. The Carbon Negative Shot specifically is focused on a broad range of carbon removal solutions. It's an all-hands-on-deck call for innovation to bring the cost of carbon removal down below $100 a ton, inclusive of really robust measurement, reporting, and verification. And marine CDR is one of the core pillars of this work. DOE is leveraging its deep expertise in novel technology innovation and commercialization to help the MCDR portfolio flourish as part of the Carbon Negative Shot. We have funded modeling work, sensor development, small pilots, and research on ecosystem impacts and community benefits to make sure that the MCDR field can catch up and be a key piece of this carbon negative shot ecosystem that we see as critical for all of our climate and economic work going forward. I also want to recognize that DOE alone won't be able to achieve the carbon negative shot goals. Only by collaborating across agencies, including our highly impactful collaboration with our colleague NOAA, despite the occasional confusion of NOAA the person versus NOAA the agency, it's been a very impactful, and we're very grateful for our partners across the U.S. government and with industry and civil society to really chart a path forward in this space that we all see as incredibly important, but still facing many uncertainties that we all must tackle. Congressional support for these efforts is clearly critical, and we're very grateful for you all convening this hearing and for us to be able to participate. So with that, I will say thank you and look forward to your questions.
Thank you very much. I now recognize Dr. Sarah Kapnick for 5 minutes to present her testimony.
Chairman Miller and Williams, ranking members Bowman and Ross, and members of the subcommittees, thank you for the opportunity to testify today regarding NOAA's work on marine carbon dioxide removal and providing comments regarding the committee's draft marine carbon dioxide removal legislation. I am Dr. Sarah Kapnick, the Chief Scientist of NOAA. I appreciate the committee's interest in learning more about this critical emerging field and NOAA's position as the lead agency in the federal government on MCDR foundational research. As the leader in the ocean observations and modeling with an emphasis on long-term monitoring and research, NOAA is ideally suited to analyze the potential of MCDR efforts. MCDR is projected to be a major economic sector with the Earth system impacts that transcend national borders. NOAA views MCDR engagement with the MCDR field as necessary to ensure safe, accountable development of potential future deployment, as well as continued U.S. leadership of the field. MCDR approaches enhance natural ocean processes that draw down carbon dioxide from the atmosphere. NOAA stands at the forefront of supporting this foundational research that is a critical tool for decision makers to assess if, how, and when this industry can safely upscale. The field has tremendous potential to make a positive climate impact and spur economic growth. However, fundamental questions remain about the safety, efficacy, and sustainability of MCDR pathways. We cannot afford to remain on the sidelines of the field of research for the climate, for economic potential of the sector, and for our national security. Due to growing interest in the voluntary carbon market, some companies are already pursuing small-scale MCDR pilot studies both in the U.S. and abroad. As a Department of Commerce agency, NOAA recognizes the importance of enabling markets while minimizing risks to our ocean communities and ecosystems. To ensure accountable growth in this fast-paced sector, NOAA must improve our MCDR knowledge base and global observing capabilities while continuing to ramp up our efforts to engage invested communities. NOAA has 4 main functions in the federal approach to MCDR. 1, providing foundational ocean and atmospheric research and leading research in the efficacy of and potential ecological responses to MCDR pathways. 2, coordinating federal, academic, and non-governmental MCDR research to inform decisions about potential future deployment. 3, addressing ecological considerations through regulatory authority and by providing guidance on research to inform the MCDR permitting process in federal waters in collaboration with the EPA and U.S. Army Corps. 4, managing MCDR research data archives to ensure the data are publicly findable, accessible, interoperable, and reusable. NOAA's 2023 strategy for MCDR research lays out our vision for how the agency can work with its partners to act in these roles. Over the past year, NOAA, as a co-chair of the Interagency Fast Track Action Committee on MCDR, together with OSTP, also led the development of a federal MCDR research strategy, a process which included multiple listening sessions to gather public comment for consideration. The strategy, expected to be released imminently, outlines research, permitting, and partnerships needed to inform decision-making about the potential future MCDR scaling. NOAA's MCDR research is anchored by the investments in leveraging the National Oceanographic Partnership Program, or NOP, and funding from the Inflation Reduction Act. In 2023, the NOAA-led NOP portfolio funded the first large-scale public multi-partner research specifically focused on MCDR approaches. These projects required applicants to provide education and outreach plans to ensure that the researchers open a dialogue with the invested communities. The initiative is primarily made possible by funding provided by Congress through the Inflation Reduction Act. NOAA is building the knowledge necessary to understand the effectiveness and ecosystem responses to MCDR and to keep the U.S. positioned as a responsible leader in the field and in climate mitigation more broadly. NOAA cannot do this alone. Partnerships within and outside of government, such as our highly successful collaboration with DOE, enables a comprehensive response to the scientific, technical, and economic questions and opportunities raised by MCDR. Support for this work will greatly advance the federal government's ability to meet these challenges and threats to our national security. NOAA appreciates the committee's dedication work on this legislation to guide marine carbon dioxide removal work. Although we note the bill does not provide additional appropriations, which would require NOAA to reduce other activities to fund additional MCDR work. We look forward to continuing the work with the committee and are happy to provide technical drafting assistance to the committee as they further consider this bill. Thank you, Chairman and ranking members and members of the subcommittees, and I look forward to answering any questions you may have.
Thank you very much. I now recognize Mr. Ben Tarbell for 5 minutes to present his testimony.
Thank you. Chairman Williams, Chairman Miller, Ranking Member Bowman, Ranking Member Ross, and members of the subcommittees, thank you for the opportunity to testify today. My name is Ben Tarbell, and I'm co-founder and CEO of Ebb Carbon, a U.S.-based marine carbon removal and ocean health company. Ebb Carbon's mission is to remove billions of tons of excess CO2 from the atmosphere. To achieve this, we're pioneering an approach called ocean alkalinity enhancement, which boosts the ocean's natural ability to safely capture and store carbon by removing excess acid from seawater. According to reports by both NOAA and the National Academy of Sciences, our approach offers one of the most scalable and cost-effective solutions of any durable carbon removal pathway. Since 2023, Ebb Carbon has been demonstrating our technology in partnership with DOE and NOAA at the Pacific Northwest National Laboratory in Sequim, Washington. This work is designed to ensure that every step we take from research to deployment is grounded in rigorous science. At Ebb, we say that how we remove the first 1,000 tons of CO2 will determine how we remove the next billion. We're following our demonstration at Sequim with a pilot scale project right down the road in Port Angeles, Washington, so we can translate what we've learned in the lab to real world operations. We're the first company to apply for a permit to operate a project like this under the Clean Water Act, and we're working closely with state and federal agencies and local communities as part of that process. We founded Ebb because we saw the immense potential of marine CDR to mitigate climate change. Oceans cover over 70% of the Earth's surface and play a vital role in regulating our climate. The ocean has already removed billions of tons of excess atmospheric CO2. And yet, despite this potential, marine CDR has yet to receive investment proportionate to its potential. As such, our ability to advance the science and the industry is limited in the United States. But this can change. I know this because I've seen it from my previous work helping grow the solar energy industry. In the early years, solar technology was promising, but not widespread. By the 1970s, solar panels were available, but cost over $100 per watt, way too expensive for most practical uses. Despite its promise, the industry struggled to gain traction, and it was decades before its recent dramatic hockey stick growth. The breakthrough came from two key factors. First, public-private partnerships, and second, smart policy enablement. While DOE labs like NREL were critical to enabling the foundational science, the cost trajectory was driven down by commercial demonstrations and deployments, which allowed the promise of solar to be realized beyond the lab and into the real world. While the national labs provided answers that helped unlock the market, smart federal policies accelerated the private capital investments required to deploy at scale. Key initiatives such as the investment tax credit provided financial incentives and market de-risking, making solar investments more attractive. As a result, the industry flourished and the cost of solar panels plummeted to less than 50 cents per watt. What was once a niche technology has now become a cornerstone of global energy production. Today, DOE's PNNL and NOAA's PMEL, alongside academic labs, continue to lead the research so critical to advancing the field of marine CDR. But as with solar, industry partnerships are critical to demonstrating in the real world and advancing the science required to deliver a planetary scale solution. Unlike with solar, we don't have decades to get this right. It is with this context that I'd like to suggest 3 areas of priority for consideration. First, direct innovation and deployment funding to marine CDR proportionate to its potential as a climate solution. This can and should include federal funding for research and development, as well as the expansion of incentives and enablements for industry deployments. Second, enable public-private partnerships to advance the field safely, effectively, and responsibly, including accounting for the role of the private sector in creating business models and deployments that can scale climate impact. Third, modernize permitting pathways. The basic science around ocean alkalinity enhancement is well established. Moving the field forward requires permits for in-water pilots to advance our collective understanding and ultimately to reach scale safely. We're at an inflection point where we have a narrow moment to move from possibility to reality, from R&D to a scale where we can have a substantive positive impact on the climate. Congress has a unique opportunity to enable the burgeoning marine CDR industry at this critical time. We know marine CDR has a huge role to play in stemming the worst impacts of climate change, and we're excited to work with the federal government to move the field forward. Thank you.
Thank you very much. I now recognize Dr. Scott Dawney for 5 minutes to present his testimony.
Good morning, Chairman Miller, Chairman Williams, Ranking Member Ross, and Ranking Member Bowman, members of the subcommittee. My name is Scott Dawney. I'm the Kington Professor of Environmental Change at the University of Virginia. Thank you for the opportunity today to talk about the challenges, potential risks, and also benefits of marine carbon dioxide removal. While some of these approaches show great promise, none is ready yet for deployment at scale because of gaps in our knowledge of science and engineering, of intended and unintended environmental consequences, and of social impacts. At present, we emit about 40 billion tons of carbon dioxide to the atmosphere every year, primarily from fossil fuel combustion. In order to stabilize climate, we need rapid decarbonization of the global economy, and eventually we need to reach a net zero human emissions of carbon dioxide and other greenhouse gases. A portfolio of land-based and ocean-based carbon dioxide removal could contribute to that effort by balancing hard-to-abate emissions, but only if these carbon dioxide removal approaches can scale safely and economically to the tens to hundreds of billions of tons of carbon dioxide per year scale. Numerous approaches have been put forward to enhance carbon dioxide uptake of the ocean. As already mentioned, the ocean naturally takes up about a quarter of human emissions through geochemical pathways. These geochemical approaches, such as ocean alkalinity enhancement, would extend that uptake by adding alkalinity and increasing the solubility of carbon dioxide in seawater and enhancing the flux of gas across from the atmosphere into the ocean. Direct ocean capture would actually remove carbon dioxide from the ocean and either use it or store it in geologic reservoirs. Biological approaches have been put forward that would enhance either the biomass of carbon in organisms or in detrital material in marine sediments and coastal regions. It could also act by enhancing the biological pump. This is an action by marine organisms, particularly phytoplankton, that removes carbon from the surface ocean and transports it to the deep sea. These range from approaches such as ocean fertilization and marine aquaculture to artificial upwelling. Demonstration of safe and effective marine carbon dioxide removal requires targeted research on efficacy, additionality, and durability of these different approaches. Research and development are also needed on engineering constraints, energy demands, resource demands, scalability, and technical readiness. Progress also depends on robust and transparent validation methods, measurement, monitoring, reporting, and verification that incorporate field observations, autonomous platforms, remote sensing, and numerical modeling in an integrated fashion. This is particularly challenging in the turbulent ocean, where ocean mixing and stirring transports any perturbation to the ocean that's been added by humans away from the original site and dilutes it over time. We need targeted efforts to measure the effect of any marine CDR on air-sea gas exchange, because none of these approaches actually removes carbon directly from the atmosphere. They change conditions in the ocean and then implicitly expect that that will enhance air-sea CO2 flux into the ocean. We also need assessment of environmental and social impacts, better stakeholder engagement, and agreed upon research codes and government structures in order to move forward with field testing. A federal program is essential in determining whether some form of marine carbon dioxide removal can serve in the future as a safe and effective, scalable climate solution. Federal investments provide the unique framework for rigorous and independent and transparent research, including both validation and environmental impact assessment. Without a substantial ramp-up in federal research, the rapid technology development and ongoing pressures to address mounting climate change damages may outpace our scientific understanding. That scientific understanding is critical if we are to make informed decisions on deployment of marine CDR. Thank you, and I look forward to your questions.
Thank you very much. I'd like to thank all the witnesses for their testimony this morning. The chair now recognizes himself for 5 minutes of questions. Dr. Kapnick, most of the conversation around MCDR is in the context of oceans. But as I mentioned in my opening statement, the district that I represent borders Lake Erie, the 10th largest freshwater lake in the world. So I'm interested to know, is there potential for MCDR approaches to be utilized and scaled up in freshwater environments, including the Great Lakes? And can you walk us through any challenges that might exist when talking about ocean-based approaches versus freshwater approaches?
Chairman Miller, I love this question as a Midwesterner myself who grew up in the Great Lakes.
Nice.
We do not have sufficient observational data to be able to constrain the amounts of MCDR capable in the Great Lakes right now. And so there is a need for additional observations and modelings for us to better understand what that is. It does hold potential. And a lot of the research outlined and the research that is necessary to develop MCDR could be applied in the Great Lakes region.
Yeah, can you just touch on, if any at all, maybe some of the bigger challenges that we may face while moving into this?
The challenges are ensuring that we have the observations to know how much is being sequestered. It's the importance of measurement, monitoring, reporting, and verification. And so that sensor technology, the automated technology that we can put into the Great Lakes would allow us to be able to create that information to know how much is sequestered, but then also use it in the models to model how it's moving around, predicting it months in advance, years in advance of how it may evolve in time. We need to build that robust program to be able to understand it and quantify what the value will be there.
Thank you very much for the detail. It's very helpful for me, as I don't know everything, and it's impossible to, and probably helpful for the members on the committee as well. So thank you very much. Mr. Donnie, you previously served in the White House's Office of Science and Technology Policy, OSTP, I'm familiar with it, where you oversaw the establishment of the MCDR Fast Track Action Committee. I too served in the White House, so I know how frustrating it can be to try to push interagency coordination with committees. It's basically like herding cats, and it's not that much fun. But can you tell us the general level of interest and engagement there is regarding marine carbon removal across the federal government? We obviously have DOE and NOAA sitting here today, so if you could maybe speak to anyone else who might be interested or isn't interested but probably should be.
Yeah, and I of course, I'm back at a university, so I don't want to overstep from my federal colleagues. I mean, there was a lot of interest when we developed the Ocean Climate Action Plan across agencies in climate solutions that were ocean-based, and that included marine carbon dioxide removal. So I think in addition to NOAA, there are a number of agencies that have a strong ocean science portfolio. So NSF, NASA, the Smithsonian has done a lot of work in coastal regions, but also there was interest from EPA, Army Corps. So I think there's a pretty wide space. Now, coordinating that, of course, is my colleague's job. But from the research perspective, I think one of the important things is how we would move forward in marine carbon dioxide removal in a way that complements the ongoing investments that we make in ocean science, and particularly documenting and quantifying the uptake of anthropogenic CO2 that's already happening by the ocean. So we need to understand, is that continuing? Would that be affected by other activities, by climate change? And how do we integrate that across, would we integrate marine CDR into that existing framework?
Yeah, thank you very much. And just once again, thank you to all of the witnesses. You know, like I had mentioned earlier, we have Lake Erie, one of the Great Lakes right in our district. And moving into the subject matter of expertise and area, which you all have a great depth of knowledge on, is exciting because we can actually help our area in the 7th District get a little bit better. So thank you for your time this morning. I now would like to recognize Ms. Ross, the ranking member, for 5 minutes of questioning.
Thank you, Mr. Chairman. While marine carbon dioxide removal seems promising as a climate solution, the integrity of the voluntary carbon market must be carefully monitored. This will require thoughtful development of monitoring, reporting, and verification. I know Dr. Kapnick just alluded to this, MRV, and we need strategies to ensure that the claims of carbon uptake are trustworthy. Dr. Donnie, can you describe the current status of MRV approaches for marine CDR and also tell us what's challenging about quantifying ocean carbon uptake from the atmosphere?
I think we're at a pretty good state in terms of understanding if we were to perturb the ocean, to add alkalinity or ocean iron fertilization, which has been, there are multiple decades of experiments, we're able to quantify what happens on short timescales of weeks to maybe a couple of months. I think one of the real challenges is as those signals get mixed and diluted away in the ocean, how do we monitor that on long timescales? And it's going to be some combination of autonomous platforms. You know, NOAA has an excellent depth of expertise and autonomous platforms that can measure aspects of the carbon system, combined with numerical modeling. Because once we're gone, most of our work has been you go out on a ship, you do something for a few weeks, and you watch the perturbation. Months later, years later, this carbon needs to stay away from the atmosphere for many, many years. And one of the big challenges right now is how long does water stay at the surface? Because I said, what we're trying to do is modify the gas exchange. If that water gets subducted away from the surface, it's no longer in connection with the atmosphere. So that's a key area that a lot of both observationalists and modelers are working on.
Great, thank you. And that's perfect, a perfect segue to my question for Dr. Kapnick. How would ocean observations need to be expanded to support MCDR MRV activities?
We would need to be able to better model and constrain what is happening with the carbon in the ocean system, as was just mentioned by Dr. Doney. With this, it depends on the scale of the activities and where we plan to do them. But to create a really robust system of understanding, we need more ocean observations, particularly our autonomous observations, to be able to know where carbon is moving through the system. The goals of it are at least 100 years of sequestration into the ocean system. So we need to be able to model that out with the observations that we have as they go in, but also our observing system our modeling system over time, predicting where that is going to go, where in the currents, where in the column of the ocean. But then to do that and to do types of pilot studies of modeling and understanding the ocean, we need to have observations at those different depths of the oceans to be able to track it and understand it, and also give predictive capabilities of where things will go into the future.
And that costs money.
Yes.
Just pointing that out. You might need some more money because we talked about the bill, and I know that there's no additional funding in the bill. So, great. So my final question is for Dr. Kapnick and Mr. Deitch. I had the good fortune last year of going to Norway to visit Equinor's Northern Lights carbon storage terrestrial carbon capture project. And I know from my previous conversation with Dr. Kapnick that there are demonstration projects that deal with MCDR in Singapore and Canada and the UK. So how can the federal government responsibly collaborate with other nations to advance MCDR research and development?
Importantly, on the science side, we have our scientist collaboration and working across the world on these types of problems. Part of the reason we're seeing these projects go overseas is they're providing incentives to companies to go there. And so here in the United States, important parts of the protection of that and of the field and the development of technology, we've been working with U.S. Patent Trademark Office to make sure that there is patent protection for these things. So if they are also going overseas, that they have that protection.
And I'll add from the DOE's perspective, we enjoy great bilateral collaboration on the R&D side with many of those nations that you mentioned, but also through the Mission Innovation Platform, there is a dedicated carbon removal working group, and they are exploring how we can harmonize the standards for measurement, reporting, and verification across that system. And so I think there are opportunities internationally to work both bilaterally and multilaterally to advance this field responsibly.
Thank you, and I yield back.
Thank you, Ms. Ross. I now recognize Mr. Bowman. Excuse me, I now recognize Mr. Williams. My apologies. Rough morning for me, huh?
It's New York either way. That's true. Good morning. Thank you for your testimony. Dr. Kapnick, one of the effects of the increasing levels of CO2 in our atmosphere is said to be increasing the acidity of the ocean. Can you talk about that, the effect of increasing acidity in the ocean?
Yes, increasing acidification in the ocean, so that as the carbon dioxide in the atmosphere is absorbed into the ocean, the seawater becomes more acid. This has documented negative impacts on ecosystems and marine life. One of the most well-known examples of that, that's very visual, is the change in shell formation, the ability of shells to form. And so we see these effects on small plankton and small animals, but we also are seeing it in larger and larger animals, in Dungeness crab and different types of shellfish. And that can affect the entire ecosystem as it continues, which is why marine carbon dioxide removal also can play an important role, because one of the co-benefits of it is that particularly ocean alkalinity enhancement can have a local impact that reduces that local acidification.
But isn't the purpose, and forgive me, this is an honest question, in the purpose to actually sequester CO2 from the atmosphere into the ocean? Isn't that the purpose of MCDR?
MCDR's primary purpose, and the reason we're talking about it, is the removal of carbon dioxide from the atmosphere and the sequestration. But one of the
Into the ocean?
into the ocean.
Okay.
But one of the co-benefits of that would be you can have local reduction in acidification. So you add crushed limestone and impacts into the ocean, or through electrochemical processes, you actually reduce the local CO2 in the ocean, which then can also counter those effects of the rising acidification due to the natural processes. So this is actually
I actually know a lot about cementitious chemistry and materials. So again, just to make sure I understand, excuse me, that we are looking at ways of affecting the ocean to absorb more CO2, and then we're going to treat the ocean with things to raise the pH, the calcium oxides, to actually mitigate the effect of having just increased the acidity of the ocean. Is that correct? I'm pretty sure that's just what you said. I think if I mischaracterized that, I'd like to know.
It's not, so also with the biological capabilities of MCDR, it is taking that into storing in biology, so in seaweed, in nutrient fertilization, into biology that then sinks to the ocean floor. And so it's removing it from the surface ocean and from the atmosphere, storing it away in a biological sense that then sinks to the bottom.
But not necessarily transferring it directly to the water.
Correct.
You said it's bound perhaps in seaweed, et cetera.
Yes.
Okay. You know, it's interesting you brought up Dungeness because the Dungeness Spit, which is right next to Squim Bay, which is right next to Port Angeles, is also right next to Admiralty Inlet and the Strait of Juan de Fuca, where my submarine operated, and have a lot of time going in and out of those waters, and have spent a lot of time even in Squim Bay in particular. And that was actually, Mr. Tarbell, can you describe a little bit more about how calcium oxide is added to the ocean to counteract these the effects of MCDR?
Yeah, so in Ebb's process, we have an electrochemical system that removes acid from the ocean. So we're not adding calcium oxides. Instead, we're removing acid. And as we do, it enables the ocean chemistry to shift to convert CO2 to bicarbonate.
So you're binding acids basically in the ocean water, but it's an additive product that you're adding.
We're returning deacidified ocean water back to the ocean. We separate acid from the ocean water, and then we remove it.
If I may, just for the last few minutes, either Mr. Diker or Dr. Kapnick, can you talk about the national security? I'm sorry to cut you off, but the national security implications that you mentioned just in the last few seconds. What specifically are you concerned about for national security and the role that MCDR can play for that?
With so much interest in what the investments that we're seeing overseas, particularly in China, with over $300 million over the next 15 years to develop this technology, we need to continue to advance our technologies and ability in the United States to both have this technology ourselves, but also with the observing system and information around the ocean to be able to know if other actors are able to sequester when they start making claims about this. If we don't have the observing and modeling systems, we will not be able to know if the claims are true or not.
Thank you very much. I yield back.
Thank you, Mr. Williams. I now recognize Mr. Bowman. If I may-
Thank you, Mr. Chairman. Mr. Deitch, the DOE is no stranger to community engagement for projects in sensitive ecosystems. Can you describe how DOE and their labs would involve the local community and ensure that their concerns are heard before conducting any marine carbon dioxide removal demonstration projects?
Yes, thank you, Mr. Bowman. So for all of our projects, the Department of Energy requires community benefit plan frameworks to be considered. These are multifaceted processes to both engage the communities and really understand not just the environmental impacts, but the broader social, economic, and workforce impacts of these projects. We think that's a critical element of our program evaluation and project evaluation specifically, alongside the more conventional technical, economic, and other considerations we have. So that's embedded in our project evaluation framework. We've also released responsible carbon management principles, which we hope will help inform developers across the carbon management space, including the marine CDR space, as just a starting point for how they can engage with communities and what communities are expecting from them in terms of engagement and making sure that projects are done responsibly.
Thank you. Dr. Doney, what type of negative impacts of MCDR should cause researchers to stop and reassess or consider ceasing development of a given MCDR approach? In other words, what are some possible show-stopping issues for MCDR?
Some of the areas that we still have uncertainty is, as we perturb the ocean, how is it going to affect marine life? And in particularly marine life that's protected species or commercial fisheries or other parts of the ecosystem that are culturally or economically valuable. So I think it's hard to say where that line is on a showstopper because, of course, there are going to be trade-offs. Any aspect of carbon dioxide removal will have trade-offs. But I think right now what we need to better understand is, for example, alkalinity enhancement. How is that going to affect organisms? As Dr. Kapnick talked about, there's been a lot of work by NOAA on looking at how organisms respond to acidification. There's been less work on the opposite side. If you add alkalinity, you make the water more basic. What's going to be the impact short-term and long-term on organisms?
Thank you. And lastly, Dr. Kapnick, what are the most pressing concerns about the impact of MCDR on the marine environment? How can we monitor for these impacts in the research and development process so that they can be properly mitigated or avoided?
Yeah, and that's why NOAA is critical in this space due to our mission of stewardship. We not only monitor what is the ocean chemistry, modeling where the carbon is, where it's moving through the system, but it is also our mission of fisheries, of the ecosystem health, of ensuring what we are doing doesn't have impacts and being able to have an understanding and tracking of what those impacts might be. And it's not only out in the ocean, but we also, in all of our work, we do laboratory tests and understanding. And we have, I welcome any of you to come to our laboratories that have coral reefs where you can actually go see the corals, where we understand how they're affected by acidification and different factors. We actually have them in tanks. So we are able to do the end-to-end research on what is happening with ecosystems to understand it, and then use our models to also envision future worlds and what may happen in future worlds to be able to assess that further. And so it's having a holistic, fundamental research program is critical to understanding this problem and what it will look like into the future to be able to answer all the questions that you have. Thank you for your question.
Thank you. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Bowman. I now recognize Mr. Kane out of New Jersey for 5 minutes of questions.
Thank you, Mr. Chairman, and thank you to all of our witnesses for being here today. Marine and ocean technologies provide Americans with significant benefits across numerous industries, contributing $432 billion in goods and services to the United States economy and supporting nearly 2.3 million jobs annually, according to NOAA. Dr. Doney, how do investments into developing marine CDR technologies benefit Americans outside of emissions reduction potential?
I think that depends if some of the approaches have co-benefits. We know quite a bit now about the sort of coastal blue carbon space, whereby protection and restoration of carbon-rich marshes and seagrasses, we could actually provide, huge conservation benefits, biodiversity benefits, and also carbon removal. One of the areas of research we need to pursue is, are there similar co-benefits, for example, by expanding, protecting seaweed beds, natural seaweed beds? For things like alkalinity enhancement, some of the electrochemical approaches actually generate co-products. Some of the companies out there, through the electrochemical approaches, are generating, for example, hydrogen. And so we need to look at what these co-benefits are and see how they fit in. Some of the companies that are pursuing direct ocean capture are looking at reusing that carbon dioxide. So rather than sequestering it, bringing it back into the economy. So you'd have to balance out, how much carbon is removed versus what are these economic and other co-benefits that might occur.
And what are some of the economic benefits for states and entities that do invest in this type of technology, and how could more research help understand these benefits?
Well, as Dr. Kapnick and Dr. Deitch have noted, we need to observe the ocean, both in its current state and for marine carbon dioxide removal. These are very advanced technologies. I work a lot with folks at Rutgers who have developed glider technology for measuring off the continental shelf, adding new sensors. We could be at the forefront of these autonomous platforms and sensors. We've done a lot of the work already, but we need to maintain that position. And the sensors that are developed have lots of other marine applications. So I think an investment in this technology could really expand our ability to work in that space.
In your testimony, you state that there are trade-offs exist for all CDR technologies across different evaluation criteria, but further research investment is likely warranted to support future deployment decisions. With that in mind, in the broader conversation of carbon dioxide removal and emissions reductions, are there any particular removal techniques that you would say do not warrant future deployment? And if so, for what reasons?
I guess I'd say I'd maybe frame it as the techniques that I think show real promise.
Okay.
I think some of the alkalinity approaches, because the reason why the ocean takes up carbon dioxide from the atmosphere anyway is because it's alkaline. And in fact, the long-term fate of all the carbon we emit to the atmosphere, almost all of it will eventually end up in the ocean because weathering products add alkalinity to the ocean. So in that sense, the more geochemical approaches are just accelerating an ongoing natural process, speeding up the ocean uptake. And I think there's a lot of promise there.
Okay, thank you. And Mr. Tarbell, in your testimony, you state that public-private partnerships have the potential to advance the field as it relates to the safety and efficacy of marine carbon dioxide removal. To date, what advancements have you seen in this space already where the private sector is making a difference in MCDR that the federal government could not on its own?
So this has been the focus of our collaboration with NOAA and DOE in our work at Pacific Northwest National Labs. And it's focused on the science of safety. It's focused on the science of efficacy, of proving that we're pulling CO2 out of the air. Excuse me. I think what private industry does well is innovation and pace of scale, and what the government is proving to do well is supporting basic research, supporting science, supporting guardrails and guidelines. And so the collaboration between the two is helping us advance a solution that has promise.
Yeah. Okay. Thank you. I yield back.
Thank you, Mr. Kane. I now recognize the ranking member of the full committee, Ms. Lofgren, for 5 minutes of questions.
Thank you, Mr. Chairman. First, I'd like to ask unanimous consent to put my statement into the record.
Without objection, so ordered.
And then I'd like to say, I think this is one of the most important hearings that the Science Committee has had this year and maybe in many years. We're at a point where eliminating emissions is not enough. We're going to need to remove carbon to have a future as a planet. We know that. And the role of carbon removal in our oceans is an important one, but not an easy one. Listening to all of you and reading your testimony, You know, we've got a situation where the ocean itself is in trouble. I mean, we've seen the reefs dying off, and that will have implications for the planet in terms of food supply and the like. How we are going to remove carbon safely and permanently is something that we're grappling with. Now, one of the things that I'm interested in, Mr. Deitch, I hope I'm pronouncing your name correctly, I'm wondering, has the department done any analysis on which MCDR technologies are likely to be the most energy intensive? And I'm also wondering if we've examined the value of potential future clean energy sources like fusion, which this committee on a bipartisan basis is working hard to support. I ask that because if successful, fusion would be able to provide large amounts of 24/7 energy anywhere without an emission problem. What is your answer to that?
So it's a great question. We haven't looked specifically at a ranking of which of these technologies are most energy efficient, but instead are really focusing our strategy for innovation to understand the energy balance associated with a wide range of technologies. Our goal is to assess not just the energy impacts, but a wide range of performance and environmental impacts of these technologies. And as we learn more from early R&D efforts, use that information to inform future pilots and then larger scale demonstrations as appropriate. We also are pursuing as a department many different clean energy solutions. The Earth shots represent our kind of moonshots in that direction. We've explored how we can work with carbon removal more broadly to some energy sources like nuclear, but we have not done specific analysis on how they could couple to marine CDR approaches yet. But it's an area of importance and one that we think is worthwhile pursuing in the future.
Well, I'm wondering if any of you can answer how we calculate, if at all, the net removal of carbon dioxide for the various MCDR technologies, even land-based CDR technologies, related to emissions for the energy source that might be used. I mean, you know, if we're using fossil fuels to support this, we're defeating ourselves. How are we calculating that?
So whenever we think about the carbon impacts of a technology, we look at what we call cradle to grave life cycle impacts. And so we try and understand all of the upstream emission impacts as well as the carbon storage benefits of this for all of our approaches. And DOE has published guidelines for some carbon removal solutions. We hope to expand that in the future. And we also support our national labs to conduct analysis on that topic, and are eager to support a wide range of carbon removal solution efforts to make sure that we do capture all of the upstream and downstream impacts of these technologies.
Mr. Tarbell, thank you so much for your testimony and for the work that you're doing. How do you ensure that the energy used for MCDR comes from clean energy sources? And additionally, if you are using clean energy sources, that is not diverting clean energy from other uses so that they would need fossil fuels. Can you address that?
Yeah, so our approach, starting with first principles, is one of the lowest energy intensity approaches to electrochemical marine CDR. And so we start by using less energy. When we use energy, we can use it intermittently, so our system is quite flexible, and that's intentional in order to accommodate low carbon sources of energy that are prevalent today, like wind and solar. We can essentially use industry best practices to account for the hourly energy, carbon intensity on the particular node of the grid that we're operating. And so we can essentially sum up the carbon emissions associated with that generation and then subtract that from what we have removed from the atmosphere.
You're not able, I'm sure, to monitor diversion of those energy sources from other potential uses.
One of the intriguing possibilities here is because we're operating intermittently, because we can be flexible in the way that we demand energy, we can actually support the growth of intermittent sources like wind and solar. So instead of necessarily taking away from the production of low carbon energy, we can actually stimulate the growth of wind and solar on the grid.
I could see that as a concept, that makes sense, but it's not a monitoring scheme. So I look forward to further research on this, and I know my time is up, so I yield back, Mr. Chairman.
Thank you, Ms. Lofgren. I now recognize Mr. Fong out of California for 5 minutes of questions.
Thank you, Mr. Chairman. Mr. Deitch, you mentioned, is that how you pronounce? Yeah. Okay. You mentioned the need for a strong and science-driven market for carbon credits in your testimony. Broadly speaking, what are some of the challenges right now with the voluntary carbon market at present, where science-driven decision-making is not necessarily occurring?
Yeah, thank you. I think when we think about the voluntary carbon market, the product that we're really delivering is integrity. Without that integrity, nobody believes that the carbon that you're claiming is real, and that credit has very little value. And so our administration has committed to a set of voluntary carbon market principles really focused on additionality, permanence, a number of criteria about ensuring that all carbon market credits in the voluntary context are done with the highest integrity possible. We see a significant opportunity for CDR approaches to have really high integrity, and at DOE, that's really where we contribute to the voluntary carbon market. And many of our investments are designed specifically to that. The chairman mentioned our ARPA-E program really focused on making sure that the sensors and modeling are robust for these technologies, because we see that as equally important as the actual technology development itself. But the flip side of that coin is that the voluntary market is still far too small to support carbon removal at the scale that we ultimately will need, and critically in the near term for it to commercialize. So one of the key things is to make sure that not only we do technology development and really robust measurement, reporting, and verification, but that corporate leaders continue to step up and invest more in these high integrity credits, even if they cost more than what the market has historically paid for carbon credits, knowing that that integrity is really robust.
So that leads to my next question, which is, given your experience working in carbon capture and removal in both the private sector and now at the Department of Energy, can you explain what warrants federal investment in marine carbon dioxide removal? Like, in other words, what does the federal government stand to gain through millions of dollars being invested in this type of R&D?
So I think investment in this field can provide a number of really important benefits. The first is expanding our toolkit as we think about how do we actually achieve the carbon removal outcomes that we need, and making it more accessible to a broad community of stakeholders across the United States. The second piece is the co-benefits that have been mentioned, and if we can figure out how to deliver carbon removal really responsibly, in many cases, we can unlock a wide range of co-benefits, as we've heard here, from local reduction in ocean acidification, potentially helping bring on more clean electricity to the grid, as well as many other local benefits to ecosystems. And only by investing in that early stage R&D will we be able to figure out how to do that in a responsible manner.
My last question, certainly this hearing is focused on marine carbon dioxide removal. How do you compare it to other carbon capture technologies?
So when we think about the carbon removal portfolio, we are not trying to pick winners at the Department of Energy. We've actually worked with Livermore National Lab to produce a report called the Roads to Removal Report. And if you think about carbon removal broadly, there are opportunities across almost every county in the United States if you think broadly. And so what we're trying to do is encourage technology development across a lot of different pathways. There are still uncertainties across all of them, and our work is designed to try and minimize some of those uncertainties and make sure that there are opportunities for the communities across the United States.
Gotcha. So versus direct air capture or this or that, you're agnostic in terms of what would be the benefits.
We don't think of it as versus, we think of it as yes and. Direct air capture has a role in many communities, Ocean CDR, and others. If we can figure out how to develop those in parallel, it will enable us to deliver the overall CDR outcome more effectively.
Certainly appreciate that. Mr. Chairman, I yield back.
Thank Thank you, Mr. Fong. I now recognize Ms. Bonamici from Oregon for 5 minutes of questions.
Thank you, and thank you to the chairs and the ranking members, but especially to the witnesses. I represent a significant portion of the Oregon coast. I also co-chair the Oceans Caucus and have served on this committee for years, working on a bipartisan basis on both ocean acidification legislation and blue carbon legislation. So I'm grateful for the conversation today. More recently, I've been working with Mr. Tonko of this committee on the best approach, science-based approach to strengthen federal MCDR research to provide robust community engagement, including community benefit planning, which I know came up this morning, and to build a foundation to really evaluate these technologies for future development. I look forward to working not only with Mr. Tonko, but others on this committee, with NOAA and other stakeholders as we introduce this bill. Also, we're watching which I understand is coming out soon for the Fast Track Action Committee's report and recommendations, hopefully soon. And I know that some of these issues have been addressed, but I want to really dive in. Dr. Kapnick, thank you for being here. I know with Dr. Spinrad being an Oregonian, he's very familiar with this important work. As we've discussed, MCDR has great potential to remove emissions, but we have to be mindful of course, weighing the climate advantages and potential environmental and community consequences. Potential harms could be localized, especially on research sites in coastal communities affecting residents, fisheries, coastal tribes. So what can NOAA and the scientific community do to build trust with stakeholders and community members? Which of these actions, we want to, to include compliance? What would you do to include compliance with the Marine CDR Research Code of Conduct? And what role should NOAA play to really facilitate that community engagement, including providing the expertise and permitting for future research and testing?
First, thank you very much for your question and for all of your leadership on ocean issues, especially on ocean acidification. Especially with this question, thank you for allowing me the opportunity to talk about communities and the work that NOAA does, particularly with Sea Grant, where we have the engagement capacity in coastal states to be able to work with them on the engagement. It is critical for this type of work. It's critical for the development of the research plan when it's happening in our universities, but as it goes into the communities and as we experiment and then beyond, we need to work with all the communities on understanding the science, understanding what is being done, the impacts, and working hand in hand with them. Additionally, on the question of permitting, EPA and U.S. Army Corps of Engineers are the leads on permitting, and NOAA consults on those as required by law. So it's important for us to have our deep research program to be able to provide all the support that we need to and the engagements that we do in local communities.
Thank you for mentioning the great Sea Grant program. And I want to ask Mr. Tarbell, you mentioned you're working closely with local communities. Briefly, because I want to get another question in, what are you hearing from them?
Yeah, so coastal communities are some of the most impacted by climate change, as you know. And so, as we talk to them, we are understanding some of the potential tangible benefits to them. Ocean acidification is affecting local industries, the shellfish industry in the Northwest, Pacific Northwest.
Very familiar with that word.
Had to lose billions of oysters in the last 20 years. And so, the opportunities we're seeing are around helping mitigate ocean acidification, keeping homegrown innovation at home, rejuvenating local industrial sites that we'll be locating at. But yeah, there's
Thank you. And I might need to follow up on the record because I want to ask Dr. Doney, as you noted, natural-based solutions like blue carbon are more well understood. We understand the benefits. We have existing processes in place. But other methods like the ocean alkalinity enhancement or direct ocean capture require certainly a lot more research. So how can we guarantee that research is precautionary and doesn't lead to more environmental or social harm? And what guardrails should we have in place to enforce that?
Well, I think one of the things that the federal government is already doing is playing a role in setting up rules for permitting. That as we move from small-scale lab experiments to mesocosms to field pilot studies, we have the right framework. Are we doing the right validation? Are we looking at environmental consequences? Are we engaging with local communities that might be affected? So I think one of the things that the federal government can do in terms of private and philanthropic approaches is to lay out those clear guidelines and rules. And I think that's what the agencies are doing. I look forward to seeing the Fast Track Action Committee report as well.
Yeah, thank you. As someone who's experienced this over the last more than a decade, I just can't emphasize enough the importance of that community engagement with the stakeholders, with tribes and others. So thank you. I'm out of time and yield back.
Thank you very much. Now recognize Mr. Baird out of Indiana for 5 minutes of questions.
Thank you, Mr. Chairman, and I appreciate the witnesses being here. My question starts off with Dr. Kapnick. You know, earlier this year, I passed the Carbon Sequestration Collaboration Act, first of its kind federal research plan that required the department to collaborate with, coordinate with, and share data with other agencies engaged in carbon sequestration research. Collaborating agencies include the Department of Agriculture, the National Labs, the U.S. Forest Service, just to name a few. So in light of NOAA's intent to engage in carbon sequestration with our oceans, can you give us some idea on your perspective on the importance of the collaboration with these agencies in sharing data, in coordinating research plans?
Absolutely. Thank you for the question. All of our data and information that we produce abides by our principles for transparency and making it available, interoperable, being able to find it. We see an importance in building the infrastructure for that data management and availability. And in this field in particular, due to the importance and the equities of Department of Energy, we pursued an MOA with them to be able to help us outline how we should work together and to be able to launch that capability for working together. And I will even add, we even have a Sea Grant fellow working between our agencies as a fundamental glue to ensure that we are working as closely together as we can.
So any other witness have anything you'd like to add to that? Yes, sir.
So from the Department of Energy's perspective, we have a long history with carbon sequestration on the terrestrial side. The National Energy Technology Lab has done an amazing job of creating the EDX platform to share a lot of that learnings, and it has benefited industry. And so I think the lab in particular has amazing capabilities to be able to deliver on that transparent data sharing across the carbon sequestration world.
Well, you know, you have, I'm really impressed with the amount of computer capability and quantum computing that the Department of Energy has, and then to share that data across different agencies, I think increases efficiency and provides opportunity to discover additional pieces of information that we might not have now. So, Mr. Deitch, if I pronounced that correctly, since you spoke up, I'm going to ask you a question. The Department of Energy and Fossil and Energy Carbon Management has invested a number of ocean-based carbon management R&D projects and a number of projects that are located in states without an ocean on their borders, such as Pennsylvania, Kentucky, and North Dakota. So could you talk to us about the value of marine CDR research to all states, like Indiana, for example, with a number of world-class research institutions, not just near the ocean?
Yeah, so the Department of Energy works with world-class researchers, not just at our national labs, but across academic institutions around the U.S. And there's actually amazing expertise on the ocean, not necessarily located in coastal states, as you mentioned. And so I think there's an amazing opportunity to link many of those world-class research institutions with some of the early research and development projects that we're doing in order to understand how these projects work, not just from a technical and economic perspective, but from all of the other ecosystem and environmental impacts.
Thank you. Do any other witness have anything to add to that? Hearing none, I yield back.
Thank you, Mr. Baird. I now recognize Ms. Fouché out of North Carolina for 5 minutes of questions.
Thank you, Mr. Chairman, and thank you to the witnesses for being here with us today. I represent North Carolina's 4th Congressional District, and while my district does not represent coastal communities, North Carolina has over 300 miles of coastline that play a vital role in the country's economy, including soon-to-be energy development within offshore wind sector. Dr. Kapnick, in addition to federal interagency coordination, can you talk about the interstate cooperation and collaboration that needs to take place, specifically amongst coastal states like mine, to ensure that marine carbon dioxide removal research and development is executed effectively?
Thank you very much for your question. Because we're working with the ocean and there are ocean currents, things move around. Ecosystems move around, whales move around. Having knowledge and building up the understanding and working across all of the states is absolutely critical as we are able to predict and project where things are moving and the life cycle of carbon over time. I will also add something that hasn't come up is there is an entire supply chain potentially for this technology coming from Department of Commerce. The benefits won't just be in the coastal states because if you look holistically at the supply chain of what is needed to do these activities, it may include economic development that can occur far from the coast.
Can you describe any current or planned interstate regional collaborations with federal agencies on marine carbon dioxide removal?
Sea Grant, thank you for the question. Sea Grant is actually setting up a law and policy symposium on MCDR that will be occurring in a couple of months. And the reason for that is we are seeing interest across different Sea Grant programs. And so they're bringing that together to have the discussion across all the programs and do the community outreach on this issue on legal and policy issues to think through some of those hard issues that you're raising.
Thank you. And Mr. Chairman, I'll yield back the balance of my time.
Thank you very much. I now recognize Mr. Weber of Texas for 5 minutes of, excuse me. Is he, yeah. All right. I will now recognize Mr. Weber of Texas for 5 minutes of questions.
Thanks. All right. Is it Dyke or Deitch? Deitch, thank you. I appreciate you being here. In October 2023, DOE announced funding for 11 projects across 8 states. I'm sure you know that. I feel like I'm telling Noah about the flood. One of those projects, housed at the University of Texas in Austin, will study the ecosystem activity and efficacy of storing carbon in shallow seagrass beds. Given the importance of diverse ecosystems that support recreation and the economy across my district, I'm the 3 really coastal counties, starting at the Louisiana border, that other foreign country, and going down. Those situated along the Texas Gulf Coast, our ecosystem that support recreation and economy across my district, situated across the Texas Gulf Coast. Are you able to share with us any updates on that particular project?
Thank you for the question. I don't have specific updates on that project, but I can say that where we are starting our research at DOE is really not just understanding the technology, but understanding exactly those impacts to communities from an ecosystem and economic perspective as well, because we recognize how important that is. And from the very beginning of these research projects, we want to understand what those impacts will be so we can inform future deployments.
Well, we do too, giving all the recreation and actually the economy that's for our 7 ports. I guess we could probably reach out to the University of Texas there in Austin, maybe get an update on what they're finding. What role do you see for the Gulf of Mexico in the development of marine carbon dioxide removal, both in testing and implementation going forward?
Yeah, it's a great question. I think one of the important aspects of the diversity of marine carbon removal solutions is some work better in cold waters, other in warm waters. And the fact that the United States has opportunity to test both is really important, as well as in shallow versus deep water ecosystems. And so I think it's going to be a critical field where we're able to test many of the carbon removal approaches.
Yeah, I was wondering about that with your exchange with the lady before me. I think she said she's from North Carolina. And of course, that's Gulf of Mexico is a lot warmer water than, of course, the Atlantic Ocean is. Ms. Donnie, in your testimony, you described potential benefits to the ecosystems and marine life from using different techniques. For example, in referencing ocean alkalinity enhancement, you stated, quote, The resulting pH increase would also directly counteract anthropogenic CO2-induced ocean acidification that is negatively impacting marine ecosystems, end quote. You know what I'm referring to, okay? I was a little late getting in because I was with Energy and Commerce, so I didn't get to hear everybody's testimony. Mr. Doney, is it Doney?
Yeah.
Okay. Can you expand on the potential benefits of marine carbon dioxide removal and any potential pitfalls? You know, we want to also know that we want to know not just the good, but the bad. This is one of those good, bad, and ugly movies. Expand on the potential benefits of marine carbon dioxide removal and any potential pitfalls to these ecosystems that are critical to coastal communities such as my district, as I've described it, warm water Gulf of Mexico.
Right. So you already mentioned the Seagrass project from University of Texas. I think one of the, in some ways, safer approaches are these conservation and restoration approaches, such as restoring damaged wetlands or protecting carbon-rich ecosystems, because these are systems that are already functioning biologically, and if they have the benefit of adding carbon as well as biodiversity and recreation fisheries, that's great. Where I think we have more concerns is where we're manipulating the biology in a way that's different than the natural state.
I was just thinking about that. In my district, in the Gulf of Mexico, we have a lot of oyster beds. And so I guess I'm 71 years old. I've grown up in a 20-mile radius all 71 years, although a lot of people consider I'm not really grown up. But so if it was working for oyster beds, and if the natural habitat was working, are we concerned that we're changing that level somehow?
Yeah, that is one of the concerns with adding, for example, adding alkalinity, that we haven't done as much work on the local effects of what's going to happen on the ecosystem. Over long time scales, as it gets diluted out, it's probably not as big of a concern, but locally at the distribution point, it might shock some of the organisms. And as Dr. Kapnick's talked about, there's a lot of work in NOAA on the acidification side, less so on the alkalinity enhancement side.
Have you been to the Gulf Coast of Texas?
Oh, yeah.
We want you to come back and spend lots of money. I yield back.
I now recognize Mr. Casson out of Illinois for 5 minutes of question.
Thank you. So I really appreciate, thank you to the chair for having this hearing. I'm getting flashbacks. When I first joined this committee about 6 years ago, I think one of the first hearings I was in, I made the observation that the conversation about whether we need to get to zero CO2 emissions by 2030 or 2050 is sort of dumb, because a human supporting the kind of civilization we want needs CO2 to be below 350 parts per million, which means we need to stop emitting CO2 by about 1995. And in the absence of a time machine, we need what you all are doing. So we need to do it more and do it faster. Dr. Kapnick, I'd like to start with you just because first I just want to make sure I've got my numbers right, because I was looking things up on the internet and that's always dangerous. If I understand right, on the margin, if we emit another ton of CO2 to the atmosphere, about 30% of it ends up in the ocean. That right?
Yes, that is
okay.
correct.
Chalk up one to the internet. And then number two, that for every additional unit of heat that the atmosphere takes in because of anthropogenic global warming, I think about 90% of that heat ends up in the ocean. Do I have that about right?
Is also correct. The majority.
Okay, that latter number scares the dickens out of me. So I wonder if you could help out, because if we're, given as we are heating the ocean much faster than the atmosphere, and we all appreciate what we feel in the atmosphere, how concerned should we be about feedback loops, particularly on ocean acidification, right? Because if the ocean's heating up, we're increasing the solubility of CO2. Is that 30% moving? Are we seeing accelerations in acidification?
Yeah, there are concerns that it is not going to remain exactly the same over time. And that is why we have a robust program for understanding how ocean uptake may change over time. And MCDR, in the thinking of doing some of the research of it, was originally to understand the carbon cycle in the ocean, understand what might happen in the future. But then as we potentially do this, it speeds up the natural processes of carbon uptake into the ocean and accelerates it to potentially being above that 30% level through active management of how the carbon is uptaken by the
But just to be clear, I want to, and I think everybody said this up here, I want to make sure that we're all clear that none of us are encouraging technologies that would increase ocean acidification. Is that correct?
Correct. We
Okay.
do not want to increase ocean acidification. We are trying to manage locally.
Okay. So then, given the higher rates of heat, how confident are you and Mr. Deitch, if you want to chime in on this as well, how confident are we that we feel good about the upwelling and downwelling plays? Because if the ocean is warming up, you know, I mean, we've got plausible risk that the Gulf Stream shuts down because places that we trusted were reliable upwelling and downwelling spots don't work anymore. It seems to me that if we're putting carbon in a place where we think we're confident it's going to stay down and all of a sudden there's an upwell, are we confident of that? Like, how should we be thinking about that?
Thank you for the technical question. I believe what you're referring to is the fact that we have large ocean currents in the Atlantic meridional overturning circulation, and there is a fear that in the coming decades that may reduce its efficacy of changing where the ocean is sinking. That is why this type of research and understanding of its impacts requires not just understanding the impacts as something goes into the ocean, then you model it out for a couple of years. It requires multi-decade, multi-century review of it, because the goal of MCDR is to at least sequester for at least 100 years, and it can be thousands of years, depending on where it's placed.
So to that end, and Ms. Ross had mentioned this trip we did to Norway together, where we went to that longshore, I think that's what it's called, where they're pumping, but they're pumping beneath the ocean surface, so it stays permanently down. I haven't heard about that. Is that one of the things that's in MCDR, or are we thinking about that in a different bucket? Because at least that way, we're not worrying about ocean acidification, and presumably we're relatively confident it stays down.
Yeah, so at DOE, we think of that as a different bucket. That's very similar to the geologic storage we do onshore here in the United States. It's similar types of technology and formations. Those storage formations are just
Are you all monitoring? I guess it's Longship. Are you monitoring that Longship process?
Yeah,
So that some lessons learned there, I would hope.
That's right. We collaborate closely. We have a bilateral agreement with the Norwegians, and we actually exchange a lot of technology learnings. They have a technology innovation center there that complements our National Carbon Capture Center.
And I see I'm about out of time, so if we don't have time, if the chair will allow you to respond, great. If not, take this for the record. We have to do what you're talking about, and the scale scares the dickens out of me. There's been some talk about operating costs, but when we were in Iceland a while ago, we were talking with the Climeworks people, and we were just sitting there which is a fascinating technology, you know, direct air capture, pulling this out, and we sort of back of the envelope, and I said, okay, if we want to take 100 parts per million out of the atmosphere to get back below 350, that's like 800 billion tons. Then we said, okay, take this facility, cost you 15 million. How many would you have to build to take out 10 parts per million? And we ran the math, and that was like 100% of global GDP. And so, like, as we think about these technologies, are there anywhere we look at and say, this has the potential physically and financially to scale to a point that matters? Because we can do a ton of these small things, but, you know, whatever, we'll sell some voluntary carbon credits, but if it doesn't matter, what's the point?
So this technology is more or less where solar was back in 1995, and that probably would have been a similar calculation if you took the price then.
Well, but I guess my challenge is that, like, these are like pumps and filters. This is mature technology, right?
We actually see massive potential for innovation across it and cost reduction.
To be continued. Thank you for giving me a few more seconds. Yield back.
Thank you. I now recognize Ms. Lee out of Pennsylvania for 5 minutes of questions. Collins for 5 minutes of questions.
I'm out of Georgia.
Out of Georgia, yeah, I'm aware. It's been a rough morning, Mike.
Too much carbon dioxide. Thank you, Mr. Chairman. And I'm bad about mispronouncing names too, so is it Mr. Tarbell?
It is.
Okay, all right, thank you. Mr. Tarbell, I think it's important that as we talk about the growth of marine carbon removal, we ensure it doesn't turn into the Wild West where some companies are claiming to do extraordinary things that end up not actually materializing. And I want to avoid anyone, especially the federal government, from being sold a pipe dream and investing heavily in bad actors perpetrating what would amount to fraud. So how do you engage with DOE's Pacific Northwest National Laboratory to conduct measurement, reporting, and verification so that the folks in the federal labs know and trust the technologies that you're developing?
Yeah, so we have a very close collaboration with the scientists at both NOAA and DOE at the project we're working on, the Pacific Northwest National Labs. It's critical for us as we grow for there to be stringent standards and transparency around the way that we measure and report on and quantify how much CO2 is coming out of the air. The way we do it is through different methods of measurement, monitoring, and modeling.
Can you get into what kind of data they are asking for?
So the data that's available is there's baseline data of the ocean chemistry. There's data around how much alkalinity we're adding to the ocean, and then there's models around how the ocean currents and ocean conditions change based on the perturbation that we're adding.
You think the data they are asking for, has it been helpful? Is it?
Certainly the collaboration with DOE and NOAA has been extremely helpful in enabling us to say with confidence how much CO2 we're pulling out of the air.
Okay. How quickly do you think your technology can be scaled upward in the next 5 years?
So the system that we've installed at Pacific Northwest National Labs is a 100-ton per year scale system. Our goal in the next 5 years is to have deployed 1 million tons per year of removal capacity. And the way we scale is by co-locating with existing industrial facilities. So desalination plants, mining installations, existing industrial facilities that are moving ocean water. We couple our system to those facilities. One large desalination plant alone can comprise 1 million tons a year of capacity.
I think that leads into my last question about, and you've pretty much answered, but if you got any more, who's going to be the primary investors besides the federal government?
So our investors to date are primarily venture capital investors, and as we grow, as we're deploying systems, it will be more infrastructure investors. So investors doing project financing, similar to the investors that fund the development of power plants or other infrastructure like that.
Okay, so they'll be investing and then latching on to like the desalination plant.
That's right. We co-develop projects with operators or owners of for example, desalination plants, right. And we bring in outside money from project finance investors.
Okay, thank you. Mr. Chairman, that's all I got. I'm going to yield back.
Thank you, Mr. Collins. I now recognize Ms. Lee out of Pennsylvania for 5 minutes of questions.
Thank you, Mr. Chairman. In October of last year, the University of Pittsburgh received over $2 million in funding from the U.S. Department of Energy to develop marine carbon capture technologies and accelerate novel climate solutions. The Pitt team will be using this ARPA-E funding to develop optical fiber sensors that will measure pH and carbon dioxide in seawater from the ocean's surface and the seafloor. Sensing technology like this could be a game changer for integration into other applications like public infrastructure to help prevent disasters, for instance, like the collapse of the Fern Hollow Bridge in my district last year. So I look forward to seeing, this particular project developed. But, just to get down to it, I was elected to this office by communities and constituents that simply seek practical solutions to everyday problems that they face. So as I continue to learn more on this subject matter, I'm curious to hear from our witnesses today how marine carbon dioxide removal plays into the bigger questions addressing the climate crisis. Mr. Tarbell, could you share more the type and volume of resources required to carry out MCDR operations?
Yeah, there's several different buckets of activity that are required to deploy one of our systems. So first, our focus historically has been R&D, so designing and engineering systems that work, that address the science and demonstrate safety and efficacy. As we scale, we veer more into the realm of deployment and the capital required to actually build out plants. And so, the resources required there are around capital investments in building out equipment. the opportunity for us to accelerate the growth of this through partnership and investments from the federal government are, primarily what we're looking for is an opportunity to level the playing field, to be tech neutral in the incentives, to enable the best solutions to rise to the top. And so, we're looking for opportunities to fund R&D, to stimulate the growth of the best technologies, and then opportunities for deployment of the technologies that are most promising.
Thank you. Mr. Deitch, R&D is it's experimental at its fundamental core. How can the department commit to partner with communities to ensure equity and reaping the benefits of carbon removal without potentially causing harm to ecosystems or local communities in poor, vulnerable regions through MCDR experimentation?
That's a great question, and it's the core of how we're approaching our early investments in research and development. We're requiring the projects to build community benefit plans around their projects that look at the broad, not just environmental impacts, but workforce impacts as well. And we're also trying to understand through these early research projects what those environmental impacts are so that we can inform not just how to mitigate any risks, but how to take advantage of any benefits that this could provide to local communities in terms of environment, economy, and workforce.
Thank you. Mr. Tarbell, again, is it a failure if R&D teaches us that this technology is not scalable to address CO2 removal at the needed level to meet our climate goals?
We should be focusing our investments on the technologies that can have an impact. Our company's mission is to remove billions of tons of CO2 from the air, and if the technology we're working on is not capable of that, we need to shift our focus to something that will.
So the climate crisis, from extreme heat to unprecedented flooding, disproportionately affects Black and Brown communities. How will the R&D of MCDR improve the lives of families who struggle to combat the daily realities of the climate crisis in their homes and communities, if at all? And that's for any who would like to answer. Oh.
I do want to say, so the federal government published the Ocean Justice Strategy last winter. There are a lot of, whether it's minority communities or indigenous communities, there are a lot of complicated issues that I don't think a lot of the research community have really addressed. And I see this as an opportunity as we move forward to do this in a better way than we've done previous research, where we've done research independently of the communities. So I see the community engagement as a really crucial part. And in part, we need to find out what the right questions to ask are.
Thank you. Thank you. I really do appreciate that answer, and I appreciate you all being here today. That's my time, and I yield back.
Thank you very much. In closing, I just want to thank all of the witnesses sincerely for their valuable testimony here this morning, and the members for their questions. The record will remain open for 10 days, and additional comments and written questions from members. Thank you very much again. This hearing is adjourned. Handed it nicely. That bitch named